Bismillahirrahmanirrahim. I am Engr.Muhammad and I am delivering the video lectures for the course of Applied Electricity and Electronics. Course code is CEE103. This course is being offered by the Department of Electrical and Computer Engineering, Comsat University, Islamabad, VAR campus for the semester of fall 2020. This is a series of lectures, and today we are going to record lecture number 6. And in this lecture, we are going to discuss numerical examples related to Ohm's law. Again, for the students, information that these video lectures are being prepared from the textbook, that is Fundamentals of Circuit Analysis by Alexander Sadiko. Let's start. In previous lecture, we discussed the theory of the Ohm's law. We discussed conductor insulators. We also discussed the relationship between power and voltage, the relationship between power and current, and we also seen the that how we can apply voltage across the resistance, so how we can classify different resistance, how we can measure the resistance, and so on, what are the units of the resistance, and so then in this lecture we are going to see the examples related to Ohm's law. So let's see example number 1. An electric iron draws current of 2 ampere at 120 volt. Find its resistance. So this is a very easy and simple example that we have an electric iron and we have connected the iron across the main terminals of the main switch line, that is a 120 volt, and assume that it is drawing a current of 2 ampere. So we have to find the resistance. So you can see from that, for this simple problem, we don't in kind of circuit, we don't need to draw in kind of circuit. We simply have to use the Ohm's law. So knowns are that we are given the current and we are given the voltage, and unknown is the resistance. So from Ohm's law we know that resistance R is equal V upon I, that is resistance is the ratio of the voltage and current. Assuming that iron is a linear element, so in this case we can apply Ohm's law. So substituting the values of the voltage and current, so R will be equal, voltage is 120 divided by current is 2. So R is equal 120 divided by 2, so this will be 60 ohms. So using Ohm's law we can find the resistance, just like I already mentioned that actually ohm meter uses this technique in a resistance. So if we apply certain voltage and measure the current, then we can find the ratio of the current, voltage and current. So using that ratio, we can say that current in a certain branch is in resistance across two terminals is certain value. So let's see another example. The essential component of a toaster is an electrical element, a resistor that converts electrical energy to heat energy. How much current is drawn by the toaster with a resistance 15 ohm at 110 volts? So problem is that we are given a simple toaster. We can assume that from electric circuit analysis that a toaster is a resistor. So its function is that it converts electrical energy to heat energy. Also from electrical point of view, this statement is not that important. The important part is how much current is drawn by the toaster with resistance 15 ohm at 110 volt. So you can see that we are given the resistance of the toaster, that is 15 ohm, and we are also given that that toaster is connected to 110 volt supply. So we want to find the current drawn by that toaster or resistance. So given quantities are resistance 15 ohm, voltage 110 volt, so we have to find the value of I. So from Ohm's law we know that I is equal to VI, V divided by R. Already we know that V is equal to I into R, so we have to solve that equation for I. So we can say that I is equal to V divided by R. So since we are given the value of voltage, that is 110 volt, and we are also given the value of resistance, that is 15. So we can simply divide these quantities. So I will be equal 7.33 amperes. So again, you can see that since resistance is very small, so in that case toaster will be using much larger amount of the current. So it means that actually it needs larger power. So let's see another example. In the circuit shown, calculate the current I, the conductance G, and the power P. So this is the circuit. In this circuit, there are two elements, that is voltage source 30 volt and its positive polarity is upside and negative polarity is downside. So applied voltage are 30, and these 30 volts are applied across the resistance whose value is 5 kilo ohm. So obviously when we apply 30 volt, a certain amount of current will be flowing through this resistance. That current again we can find using Ohm's law. So problem is that we have find that current I, also we have find current conductance G, and we have to find the power that is dissipated by this 5 kilo ohm resistance. So let's proceed. The voltage across resistance is the same as the voltage at source voltage, since already we mentioned that this 5 kilo ohm resistance is connected across 30 volts and there are no any other element. So it means that these 30 volts will be appearing on this 5 kilo ohm resistance. So we can see that this V is equal 30 V. So anyway, for current, because we are also given the value of resistance, and resistance value is 5 kilo ohm. So we can say that according to Ohm's law, V is equal to IR. So we can solve that equation for I. So I will be equal to V divided by R. So it means that I is equal to value of V is equal to 30 divided by R. Value of R is 5 kilo, that is 5 into 10 power 3. So this will be equal to 30 divided by 5 into 10 power 3. So 30 divided by 5 will be 6, and we can convert this 10 power 3 in the numerator. So this will be 10 power minus 3, and we know that 10 power minus 3 is milli. So this will be 6 milliampere. Another important observation is that when applied volts are in volts and resistance is kilos, the current will be automatically in milliamperes. So in this case, current that is flowing through this resistance is 6 milliampere. Again, you can see that since resistance is larger, 30 volt source actually produces much smaller current through that resistance. The conductance, again we know that conductance and resistances are inverse of each other, so G will be equal to 1 upon R. So we don't have to use the Ohm's law for this evaluation of G, and since G is equal to 1 upon R, and we have the value of conductance in resistance, so G will be equal to 1 upon 5 into 10 power 3 Siemens, or G will be equal to 0.2, that is 1 upon 5. 10 power 3 will be in the numerator, this will be 10 power minus 3, so 0.2 millisiemens. So next quantity that we want to find, that what is the power that is being consumed by this resistance. So we know that power is equal to VI, so this will be equal to, we have the value of V, that is 30, voltage across this resistance is 30, and I is equal to 6 milliampere, so 30 into 6 into 10 power minus 3, this will be 180 milliwatts. So power that is being consumed by this resistance is 180 milliwatt, or we can say that power delivered by this voltage source is minus 120 watt, or if we ignore the sign, we can say that it is still 180 watts. So this 180 milliwatt is power that is being provided by this source, and it is also by the amount of power that is being consumed by this resistance. So let's see another example. we have a circuit. So in that circuit we want to calculate the voltage V, conductance G, and the power P. So this is the circuit. In this circuit we are given a current source, that is 3 milliampere current source, and current is flowing in this direction, and we have a resistance that is connected across this current source, that is 10 kilo ohm. So we want to find the voltage V, conductance G, and the power P. So obviously we can use for evaluation of voltage we can use Ohm's law, and you can see that current in this resistance will be same as the source current, that is 3 milliampere. So in this case I will be equal 3 milliampere. Why I is equal 3 milliampere? Because starting from this point, if you trace the circuit, we can see that there is no other um, 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 uh, we can say that there is no other way for the current. There's only one way, or there's only one path for the current, that it can follow starting from this point and will flowing through the resistance. It will be going from this terminal up to this point, and then again current will be provided as 3 milliampere. So current in this 10 kilo ohm resistance is still 3 milliampere, and we can easily find the voltage using Ohm's law. We have V is equal to I into R according to Ohm's law. So since we want to find V, so we have I now, that is 3 milliampere. We have R value, that is 10 kilo. So I is equal to 3 ampere already given. R is equal to 10 kilo ohm. So we can substitute these values into this equation. So V will be equal to 3 milli into 10 kilo. So in this case we will be equal 30 volts. Again you can note an interesting point, that if current is in milliamperes and resistance is in kilo ohms, then voltage will be automatically in volts, because 10 power minus 3 multiplied by 10 power plus 3, these two quantities will cancel or divided. This will be 3 into 30 or 3 into 10 or 30 volts. So next we want to find the conductance G. So we know that conductance is given by G is equal to 1 upon R. So in that case we have the value of resistance. R is equal to 1 upon 10 kilo. So G will be equal to 1 upon 10 K. So we can easily find that this is 0.1 millisiemens. Finally, for the power, we have three different equations for the power, that is P is equal VI, P is equal to I square R, and P is equal V square upon R. So in this case, we can easily use power equation for the power dissipated by the resistance will be VI. So we have the value of V, that is 30, and we have the current equation, that is in fact current value, that is I is equal to I is equal to 3 milliampere. So power dissipated will be equal 30 into 3 milli, this will be 90 milliwatts. So this is the power that is being dissipated by or consumed by this resistance. This is also the power that is being supplied or delivered by this source. So in this case you can see that power consumed is same as power dissipated. So let's see another example. We have a voltage source of 20 sin pi t, and it is connected across a 5 kilo ohm resistance. Find the current through the resistor and the power dissipated. So again, this is a very easy problem. We are given the voltage source, that is 20 sin pi t. In this case you can see that voltage source is actually changing, or depending on the time source. So this is actually time dependent source. So it is connected across 5 kilo ohm resistance. So we have to find the current through that resistor and power dissipated by that resistor. Still, because we want to find the current and we are given the source voltage and resistance, so we can use Ohm's law. So we know that V is equal to IR, so we can solve even this equation for V, in fact I. So I will be equal to V upon R. So in this case I will be, because V is equal to 20 sin pi t divided by R is 5K. So current will be 20 divided by 5k, so this will be 4 sine pi t milliampere because of this kilo. Again, remember that now since voltage is in volts, so and resistance is kilo, so current will be in milliamperes. So for next we want to find the power dissipated by the resistor. So we know that P is equal to VI. So in this case P will be equal to V is equal to 20 sine pi t multiplied by I is equal to 4 sine pi t. So we can multiply these two quantities and we can say that this will be 4 into 20, 80, sine into sine square pi milliwatt. So this is the power again consumed by the resistance, or this is the power delivered by the 20 sine pi t voltage source. Let's see another example. A resistor absorbs an instantaneous power of 30 cos square t milliwatts when connected to a voltage source of V is equal to 15 cos t volts. So we have to find the current I and resistance R of the resistor. So in this case, we are given the power that is being consumed by the resistor, and we are given the voltage source that is applied across the resistance, and we want to find I. So again we can use the power equation. We know that P is equal to VI. So for I we have solved this equation. So from this equation we can say that I will be equal to P divided by V. So P is equal to 30 cos square milliwatt divided by 15 cos t. So we can cancel one power of cos 30 divided by 15 will be equal to 2. So this will be 2 cos t milliampere because power is in milliwatt and voltage in volts, so current will be in milliamperes. For second part, that is resistance, we can use the Ohm's law, that is R is equal to VI. Remember original equation is V is equal to IR, so R will be equal to V upon I, so V is equal to 15 cos t divided by current. Already we have found that current is 2 cos t milliampere, so in this case resistance will be 15 divided by 2, 7.5. Cos can be cancelled, and since in denominator we have milli, so it means that resistance will be in kilos. So R will be equal 7.5 kilo ohm. So you can see that resistance value is fixed, but value of voltage, power and current are actually time dependent. So in this way we can use the Ohm's law or power equation to find the power, current and voltage or resistance if such quantities are unknown. So thank you so much, and next will be seeing some more topics and problems.